What we're going to be going through today, it's around this, this theme we talk a lot about at MongoDB. It's that basically every company is becoming a software company. And so the idea underpinning it is that regardless of your region, your industry, what type of company you are, accessing your data, using that to push sales, using that to form strategic decisions, things like that, is becoming increasingly important to differentiate yourself as a company. And so to walk us through how you can make an operational data store to get real-time insights into your data, please welcome to the stage developer advocate from MongoDB, Mira Vlaeva, and product manager from Google, Etai Margolin.
Thank you. Hi, everyone. All right, so I'm Itai, and this is Tanimir. And today we're going to show you how easy it is to create streaming analytics, real-time streaming analytics pipelines from your operational database. All right, so we'll talk about, first of all, big picture, streaming analytics. You guys all know what it is. We won't spend a lot of time on that. A few of the key benefits of using Datastream and MongoDB. We'll go through a demo, which will be the main part of our talk today. We'll go through a demo of setting it up and show you some cool capabilities. And we'll finally wrap up with some Q&A and additional resources for you to follow up on if you want. OK, so big picture. Before we talk about the actual solution, let's talk about some of the challenges. So today, a lot of customers, you guys know this, you have a lot of different, your data is residing in a lot of different places, different databases, different applications, and this data is not consolidated. There are barriers between those different data silos. And if you do have any kind of data integration processes, a lot of the times these are batch processes. So you're doing a batch load once every few hours, once every few days sometimes, to get the data from that operational database into your analytics stack. And then a lot of the times we see customers who have self-managed solutions, something that they built on their own, or something like an open source Debezium. And these solutions are very often very expensive and, to run and maintain. So combined, we have this situation where even if you do have a data integration solution, a lot of the times it's expensive, it's fragmented, and your reporting becomes slow and out of date. And we hear a lot from companies, from customers, from analysts about how change data capture is becoming a key component in real-time data analytics for business operations. And here's a quote from IDC. We have a few others. We won't go through them today. So now let's start talking about the pieces of the component. So the first piece is Datastream. Before we actually talk about Datastream itself, let's quickly talk about change data. So a lot of the times when you say CDC, change data capture, people tend to associate that with a database capability. And we see this much more broadly as an data architecture building block, and really the ability to capture changes wherever they happen. It can be a database, it can be a SaaS, it can be a file store, devices generating events. All of these can be sources for change data streaming. And with change data streaming, there are a lot of different capabilities that you can achieve. So obviously, analytics is the main one we'll be talking about today. But once you have a CDC solution in place, you can actually enable a lot of other use cases on top of that as well. So things like database replication and minimal downtime migrations, hybrid cloud replication. Of course, event-driven architectures, being able to react to changes across your organization from changes in different sources. And more. So we like to think, again, emphasize that don't think of Datastream and change data streaming just for analytics use cases. Once you have this kind of a solution in place, you can do a lot of things with it. So talking about Datastream, real quick, starting from the middle. So Datastream is a serverless product. It lives in Google Cloud in a private project, so you don't have to worry about setting up resources, scaling up, scaling down. This is all automatically handled for you. It's very easy to set up. You'll see in the demo, we have a very clear, very simple UI to give you all the information up front, really set you up to succeed as you're configuring the process. We support a range of connectivity options, so anything from IP allow listing, SSH tunnels, and of course, private connectivity over VPC peering. And finally, being part of the Google ecosystem, it's a very flexible solution. We have integrations with other products in Google Cloud, Dataflow, Dataproc, Data Fusion, BigQuery, Spanner, Cloud SQL, all of those are working with us together. Looking at the sources on the left-hand side, so we have currently, we support MySQL and Oracle. Postgres is coming a little bit later this year, followed by SQL Server. We're also working with Spanner, with Cloud SQL, obviously with MongoDB, to add more and more sources. And we're also working on an extensibility framework that allows customers and partners to build their own connectors into the platform. In terms of destinations, Datastream currently writes the data into GCS, cloud storage, in either Avro or JSON format, but we are adding additional destinations, native destinations such as BigQuery, Spanner. We also have, like I mentioned before, integrations with Dataflow, Dataproc, Data Fusion to add, to extend the solution further into a wide range of destinations. And I'll hand it over to Stanimir.
Thank you, Itai. The other piece of the puzzle is MongoDB Atlas. MongoDB Atlas is a developer data platform integrating a multi-cloud database service with a set of data services for modern developer experience. At the core of the platform is our database service, the core MongoDB database now offered in the cloud. From the very beginning, MongoDB was built for the cloud with scale-out architecture thanks to features like sharding. Another key feature of MongoDB, as you all well know, is the document model. The document model is a flexible data model that allows you to store data of any structure inside your database. Combine that with the aggregation framework and the MongoDB Query API, and you can perform powerful analytics over your data in real time. But as I said, Atlas is much more than just the core database. We have a set of services, and one of these services is Atlas Charts. With Atlas Charts, you can build powerful visualizations over your data that is updated in real time. You can choose from a wide variety of chart types. You can also combine your charts in dashboards and share your dashboards with your stakeholders. You can also embed your dashboards or charts in your applications, either as iframe or programmatically using the Charts SDK. Another service that is available right into the Atlas user interface is Search. Search is a fully integrated search capability that you can enable through the UI, and in just a few clicks, you can actually start querying your data using natural language. We're going to build a search index today, and we're going to showcase both charts and search in our demo. So speaking of demo, what is the problem that we're going to be trying to solve? Let's imagine that we are an e-commerce store. So we are called MongoDB Store, and we sell clothes online. And our objective is to maximize our revenue and enable a global search functionality in our web application. Now the problem, or our current setup, is that we're using a WR database. We're using MySQL. So how do we enable these two, maximizing revenue and enabling global search with Datastream and Atlas? Let's take a quick look at the UI so that you have some visual representation. So we have a grid of shirts. We can add a shirt to the cart, and we can check out. And checking out is creating an order. The order is saved in our MySQL database. So starting from here, we are going to build our pipeline, which is going to end up in Atlas. I'm going to hand it over to Itai as well. He's going to walk you through that process step by step.
Thanks. OK, so as Stanimir mentioned, we have events coming or being generated in MySQL. Datastream will be performing or be connecting to that database and pulling changes as they occur from the bin log and landing those changes into cloud storage, into files in Avro format. And then from there, we have a Dataflow process that is triggered through a PubSub notification every time there's a new file on cloud storage. It picks up that file, processes it, and loads it into MongoDB. So let's talk about this step by step. So first of all, in Datastream, the two things we need to do, first of all, configure the connection profiles. So these are just the metadata of how Datastream reaches the source and destination, in this case, MySQL and cloud storage. And then we have to configure the stream itself, which is the job that's moving the data. So here you can see an example of the MySQL connection profile. It's, like I said, very simple metadata, just the hostname, port, username, and password. And then similarly, we have a connection profile for the cloud storage bucket. And then to configure the stream or create the stream, this is the Datastream UI. You can see the two connection profiles that we created in advance for MySQL and cloud storage. Next, we go to the streams page, and we create a stream. And we can actually do this all from within the stream flow, but we show this here separately just for clearer visibility. So here we have the first step of configuring the stream. It's, again, just some metadata, stream name, the source, the destination, the region. Once I selected the source and destination, Datastream shows you all of the prerequisites that you need to take care of. So all the steps that you need to do, in this case, in your MySQL database, to enable bin log, to grant the permissions. So everything that you need to do is kind of like a checklist to make sure that you are ready to perform a CDC pipeline. Okay, once I've taken care of that, I can go ahead and configure or create my connection profile. Here, I'm just going to select one that I created in advance. And we run a test to make sure that Datastream is actually able to connect to the source. Again, making sure that as quickly as possible, we let you know if there are any issues. Then we configure the source itself. So here we tell Datastream what information we want to pull from the source. This can be any combination of schemas, tables, and columns. And then we also tell Datastream whether or not we want to pull the existing data, what we call backfill. So you can turn that off if you wanted to, turn it off for specific tables, whatever configuration is needed. Next, we have the configuration of the destination. Again, we choose the existing connection profile for cloud storage. And we can also optionally specify a path within that folder and the different file formats, either Avro or JSON. And finally, we have a summary of all of the configuration. We have a validation that we can run to make sure that everything is set up correctly. And this actually goes back to the database. It checks the permissions and the bin log and everything is configured correctly. So once everything is green, we can go ahead and start the stream. And then it's over to Stanimira, right? Okay, and this is what the stream details looks like. It takes about 15, 20 seconds to start running. And then it's bringing in data, both the real-time data and the starts the backfill process. Why is it not moving? Oh, there we go.
Thank you.
Sure.
Oh, sorry. So after we have set up our Datastream flow, we have to set up a pops-up notification for cloud storage. So the change data is saved into a cloud storage bucket, and the pops-up notifications role is to notify the next service that something new is actually stored in the cloud storage bucket. Once we have this notification coming into Dataflow, Dataflow is actually going to pick up the change data that is saved as Avro or JSON format, and it's going to transform it to MongoDB documents. And then these documents are going to be written into Atlas. This is how the job for Dataflow looks like. It's pretty simple. It does exactly what I told you. It receives a notification. It reads the data from the cloud storage bucket. Then it transforms it to documents and saves it to Atlas using a simple Atlas connection string and the Apache Beam library. All right, we have our workflow, and let's see if it's actually working. So here I have Atlas database with a collection of orders. I already have some orders here because I ran this a few times. And these are just orders coming in from our SQL database. I'm going to search for a specific detail for Datastream and MongoDB t-shirt to see if anyone ordered this product. Currently, we don't have such order, so that's why we don't have a document for that in our collection in Atlas. But let's go ahead and add that directly to our MySQL database as a new row in the depot of orders. So I'm going to use this VS Code extension as just a new record. The detail name is the one that I showed you, and we have a few other details that are not that important. So as you can see here, at the very bottom, we have a new row in the table, which is the order for a Datastream and MongoDB t-shirt. So now I'm going to go back to the Atlas collection and search for that. And as you can see, the workflow worked. We had our order coming into MySQL, and our setup that we went through actually went ahead and saved that as a new document in the MongoDB Atlas collection. That's pretty cool, right? And it only took like a few seconds, even though I cut out some part of the video here. But let's go back to our demo. What we wanted to achieve is maximizing revenue and enabling global search. How do we maximize revenue? Well, by introducing analytics, right? That's what everyone does. And to introduce analytics, we're going to create a few charts using Atlas charts. I'm going to jump straight to the demo to show you how to set up charts, create a new chart, and then share it publicly with the internet. So we're in the Charts tab in Atlas. We're going to add a chart. And the first thing that I'm going to select is the data source. So the data source is going to be my collection of order details in the Atlas cluster. Next, I'm going to select a column chart from the chart types we see here. For the x-axis, we need a category, so I'm just going to drag the category field from the orders. And for the y-axis, we need some sort of an aggregation. So I'm going to actually drop the price field, and I'm going to use the sum of the price of all orders for this category. And this is going to create a chart for the revenue that each category brings into our store. So for every order, we have the sum of the revenue that it brings in. We can customize the chart further. And actually, what I am going to do here is overwrite the label for the y-axis. For instead of sum price, we're going to say revenue per category, or no, just revenue. Simple as that. And for the numbers, I'm going to select dollars because we're dealing with prices here. And I'm actually going to increase the label size so that everyone in the audience see what I'm talking about. And you can see here when we hover, we see some additional details. I can give this chart some appropriate title, such as revenue per category. And once again, you can see here that if we hover over every column, we see the category and the revenue that it brings in. So what's left is to click the Save button, and we are going to go back to the dashboard. We can add as many charts as we want to the dashboard, and we can organize them also the way that we want. And I'm going to show you how to share that with anyone with a public link. You can also configure some intricate access setup, but for this demo, we're going to share it with anyone. And I also have to enable unauthenticated requests for my data source when I do that. And that's about it. Now we have a public URL that we can share with anyone, and this chart is going to be updated every 30 minutes or whenever new data comes into our collection. And it's going to be working with our operational data as well. So every time someone makes an order, the data is going to end up in Atlas, and this chart is going to get updated. The next thing that we wanted to do is enable global search. As you obviously have guessed, we're going to use Atlas Search. Again, I'm going to jump to the demo. And here, from collections, you have to go to search. I have already a couple of indexes, but we're going to build a new search index. We're going to use the visual editor because we're going to build the simplest possible search index. I'm going to keep the index name to default, and then I have to select the Datastream database and the store collection where my orders are. These are all the default settings that we have. And if we take a look at the JSON configuration, we have mappings dynamic true, which means that every field is going to be we're going to create a search index for every field that is supported automatically. When the search index is built, we are going to be able to start querying our documents using natural language. This usually takes a couple of minutes, but I promise you it's going to take less on the video. You're very, very lucky today. So when we go to query, we are going to see a sample of all the documents in our collection. So we see detail names, detail IDs, and I'm going to search for Angular and see if we find the Angular t-shirts. And there you have it. We have a few matching documents. We see the matching field. We see the score, which tells us how close the result is to the query. And we can actually see the query syntax, which is an aggregation pipeline. It's a very simple pipeline because we have just a single stage. We have the $search stage. The index name is default because we didn't change the name. And we have the text operator, and we use wildcard star because we search through all fields. You can export that to your favorite programming language, or in the real world, the language that your application uses, which is not always the same. And once you use that in your application, you can have a search field and basically global search for all the products in your application. And it's really that easy. So I'm quickly going to go back to show you the quick start tutorials that you have here in the Search UI. They guide you through setting up all the complete, setting up more complex queries using the compound operator, using facets, which is a new feature that we saw in the keynote just 20 minutes ago, and all that. So it's really powerful and easy to set up. If you want to learn more about it, just follow these tutorials, and you'll see how it works. All right, let's see what we learned today. First, we saw how to replicate changes to data in real time with Datastream. Next, we saw how easy it is to visualize and track your data in real time with Atlas charts. And finally, we enabled global search functionality using Atlas charts, again using the same developer platform, using Atlas. So thank you so much for your attention. We have also a very detailed blog post with all these setup, more specifically the Datastream part of the setup, that you can follow to get all these steps. You don't have to memorize everything, of course. And if you have any questions, you can find us at the conference. You can also find us on Twitter or at Gmail. Email, simple as that. So we have almost 7 minutes for questions, and you can add them somehow. Or you can just raise your hand and ask.
Yeah, let me bring up the mic so everyone can hear this. All right.
So we see that a lot of steps, like the data coming from MySQL, and then Dataflow in the end, and then what was the streaming, data stream in the beginning, and then cloud storage. Why all these different steps? Why not like Dataflow take it, or Datastream take it from the MySQL and put it in the Atlas? And the second question would be, whenever the changes are happening, are you writing for each transaction one file in cloud storage, or how that is triggered?
All right, great questions. So the first question, the answer to the first question is, give us time. We started with cloud storage as being a very kind of generic way to land data and pick it up through different tools like Dataflow and as I mentioned before. We are, as I mentioned, also working on additional kind of native destinations. Obviously, our interest is more Google focused, so we're starting with BigQuery, but there's definitely room to extend that into other destinations, including third party like MongoDB. By the way, we also have PubSub as a destination, so it's just a lower latency kind of integration.
Can I expand a bit on that?
Yeah, sure.
So being able to save to cloud storage actually enables a lot more destinations after that, so it's more universal.
Right.
So we support the MongoDB Atlas destination, but also many other destinations because of this universality of the cloud storage bucket.
And the second question, how do you, whether you do every transaction or bunch of transaction, how do you determine?
So,
You're writing basically flat files to cloud storage, right?
yeah, So the data in cloud storage is partitioned by time. So every minute, by table and then by time. So for every minute that there's new data, by default it's every minute, we will write a file with that data, with the data for that table for that minute. So it's not necessarily transaction bound. There can be data from different transactions within a file and data from a transaction in multiple files. It depends on kind of the length of the transaction. We will cut that file it's configurable. By default, it's every minute.
But we saw immediately the data was available by the video ad. Is it that you have to wait for 1 minute to?
There is some latency in the pipeline. Yeah, of course, working with GCS, there's a little bit more latency than what you saw in the video, but it's still on the order of seconds to low minutes. Yeah.
Thank you.
Sure.
All right. Solid questions. Any other questions? Okay.
We wanted to.
So how do you handle if one transaction has multiple items? Do you do the mapping of the transformation at this data stream level for the MySQL to the MongoDB transformation? How does that work?
Are you asking in terms of like transaction integrity or?
Yeah, where does the data transformation happen? At the data stream level?
So can you expand what you mean by transformation? If you're talking about transforming the data?
Well, data, right?
Yeah.
The documents.
It's a relational kind of data.
Oh, okay. Sorry. Got it. So that transformation happens in Dataflow. Yeah.
There's a template that you have to use. This is like a template that is being built by a MongoDB team. And this template takes care of actually transforming the data. And it happens at the data flow step.
What if one transaction has multiple items? Does it handle the same thing?
They're transformed to multiple documents.
Documents.
So every entry, every row is a document.
What kind of parallelism do you expose on the final push?
From Dataflow to Mongo? Or?
Once you landed it, the processes, if you have a very high rate, what kind of parallelism do you have in there or controls over parallelism?
So both Datastream and Dataflow are Datastream is more automatically scalable. Dataflow is to a lesser degree automatically scalable, and it will scale up or down depending on the throughput of events. So on the Datastream side, it means that we will add more readers to the source if there's more data to be read, and Dataflow will also add more workers if there's a backlog of files in cloud storage. Up to a limit, of course, which is configurable. Does that answer your question?
More or less, I was wondering about priority once you start parallelizing.
Oh, so it's a single priority. There's no precedence to specific tables. What you can do is split the process into multiple data streams and data flow jobs if you want to have that kind of prioritization.
Yeah, so Itai showed we're actually replicating changes to all tables, but you can have one stream for this set of tables, another stream for this set of tables.
Yeah.
And this should handle this use case, I think.
All right, I think we've got one more. Yeah, time for one more.
I saw some Atlas search that I joined late, but is that supported with GraphQL as well? Atlas search?
That's a good question. I think it is, but I don't want to say it with 100% certainty.
Okay, all right.
I have a talk tomorrow on GraphQL, and I'll be able to answer that question then.
Okay, all right, thank you.
Thank you. So if your source is Oracle, and do you have the capability if we're looking for specific tables to capture the change data? Or do we need to implement extra triggers or something?
Yeah, so for any source, the configuration is the same in Datastream. You can choose from replicating the entire database or specific schemas, tables, down to the level of columns that you can exclude.
Okay, and that's going to take care of itself, right? Whatever change data comes in, that's going to flow through the stream and
Correct.
visible on the dashboard.
Correct.
Okay,
Yeah.
thank you.
All right, I think that's
One
all
more
the.
over there, or
Unfortunately,
yeah,
I think we have to wrap it up.
All right. We're here
feel
if you
free
want to
to-
ask us questions.
Feel free to talk to them after, but
yeah.
Thank you, Etta and Mira. Appreciate that.
Thank you.